All right, y'all. It's that time again. It's Math with Mrs. Peters, the crazy cat lady of Hiram High School. Today's topic, finding P and Q and figuring out what to do with it once you have it. All right, so let's look at a function. We have a function here. It's f of x equals 2x cubed plus 3x squared minus 17x minus 30. And we're going to find all the possible rational roots. Now, what you have to understand real quick is that we're looking at right now, without ever finding P and Q and doing what we're going to do with it, we're looking at having to test every number on the number line. That means going from infinity to infinity until we find one that just happens to be a root, an x-intercept, a solution, or a factor of our polynomial function. So what we're going to do is we're going to make that set of numbers, instead of being infinite, we're going to make it finite, which means we're going to make it smaller and more manageable. Now, some of these won't look more manageable because you'll look at it and you'll freak out because it's going to be too much of them. But that's okay. It's still better than infinity. So let's talk about what is P. Okay, P is this last number. Okay, so in this case, P is 30. Q is the coefficient of the leading term. In this case, it's 2. Now, in order to make our set of possible rational roots, we're going to have to look at all the factors of 30 and all the factors of 2. Now, before you freak out, let's take this in slow steps. The factors of 30, okay, I have plus or minus 1, plus or minus 30. Those are obvious because 1 times 30 is 30. I also have plus or minus 2, and what it multiplies by to give me 30. And I also have plus or minus, and guys, this plus or minus stuff is a big deal because I'm just writing a shorthand of having two numbers sitting there. Okay, what two other numbers multiply to be 30? That would be 5 and plus or minus 6. Now, the factors of Q, or in this case, the number 2, is plus or minus 1 and plus or minus 2. Now, the set of all possible, okay, all possible rational roots is P over Q. All right, the easiest way to write this set out is going to be writing all the P's with the first Q underneath it, and then all the P's again with the second one. So that means I'm going to take this big lovely set right here, and I'm going to group it, and I am going to clone it. I'm going to clone it twice, because how many factors did I have for Q? I had 2. I had 1 plus or minus 1, and I had plus or minus 2. All right, now remember, plus or minus means that there's really 2 versions there. So the positive version and the negative version. So I'm going to go through, and on each one of these, I'm going to put 1 underneath. All right, and then on the lower set, we'll put 2 underneath. Now you're looking at this going, oh my God, Mrs. Peters, this is too much. This is too much. Don't worry about it. Guys, some of these numbers simplify really, really, really nicely. All right? Stop and think. 30 divided by 2 is 15. And that one's right here. Okay? 2 divided by 2 is 1. And it's right here. Okay? Oh, guess what? Oh, God, I just made a big old boo-boo in the middle of this, guys. I forgot one set of factors. Can you see what set of factors I forgot? Can you see what set of factors I forgot? I forgot plus or minus 3 and plus or minus 10. So we got to add those in too. So sometimes you find yourself doing, so I'm going to put the 1 underneath them. And I'm still going to come through here, and I'm going to go, okay, that's the same thing as 3 over 1. This one should have 2 underneath it. This one is the same thing as 5. Right, so I've actually simplified down my set even further. So my final set is actually plus or minus 1, plus or minus 30, plus or minus 2, plus or minus 15, plus or minus 5, plus or minus 6, plus or minus 3, plus or minus 10, plus or minus 1 half, plus or minus 15 over 2, plus or minus 5 over 2, and plus or minus 3 over 2. And this is for a total number of how many factors that are possible roots? That is 24 possible factors. All right, there's 24 possible roots or zeros. Now, that's not that bad. So I'm going to ask y'all to do this one. Okay, what are the roots? What's P? What's Q? Build me the set of possible roots. Yes, I include all the plus or minuses, all the fractions that's possible, and I want you to build it, and it's going to be big, but I'm not asking you to do any synthetic division, because we're going to do that with this problem here. So I'm going to actually work this one out to find all the real roots. So P is 20. Q is 2. The factors of 20 are plus or minus 1, plus or minus 20, plus or minus 2, plus or minus 10, plus or minus 4, plus or minus 5. And hopefully I didn't forget any. And the factors of 2 are plus or minus 1 and plus or minus 2. I'm going to use that good old clone and write it down. Don't y'all wish you could do this on a board? It'd be so much easier, wouldn't it? Okay, so I'm going to build my set of possibles. All right. So we'll put 1 under each one of these. And now I'm going to put 2 under these. And I'm going to cancel out the ones that simplify above. This one is right here. This one is here. This one is here. This one is here. And so the only extra ones I need to add in is plus or minus 1 half and plus or minus 5 halves. Now, I'm going to take this set right here, okay, and I'm going to use it and use synthetic division to find the correct factors. So, with that said, I'm going to start off by, and I'm going to show you how you can do this with fractions. Just because I know this works, I'm going to show you that synthetic division does work on this particular problem with fractions. So, I'm going to synthetically divide, what is it, g of x? It is 2x cubed plus 5x squared plus 8x plus 20. All right, and I am going to divide by 5 halves. All right, so negative 5 halves, and that's 2, 5, 8, and 20. 2 comes down. 2 times negative 5 halves is negative 5. Oh, cool, that's 0. Okay, 0 times 8 is, or 0 times negative 5 halves is 0s. 8 comes back. Okay, 8 times negative 5 halves gives me negative 20, and my remainder is 0. So this says I have 2x squared plus 8 is one of my factors, and this other one is x minus negative 5 halves. Now, because this is a quadratic, I suggest using the quadratic formula to go ahead and find the other two possible x's, and that's going to turn into 2 times x minus 2i x plus 2i. Yes, guys, I'm talking complex numbers. And x plus 5 halves is the factored form of g of x, which means I know where my graph is crossing the x-axis, and it only happens at negative 5 halves because the other two are complex numbers, and that means it doesn't cross the x-intercept, or it doesn't cross the x-axis. With that said, I know this was a long one. There's lots of juicy meat in this one. You're going to have to go back and listen to it a couple of times, write down your questions, bring them to class or tutoring, and I'll be happy to help you. So have a nice evening. Talk to you later. Bye. Bye.